what is quantum physics? What are its major applications, and why is quantum physics so important, and how is it fundamentally different from classical physics?
Yeah. So actually, quantum physics is very important from the point of view of quantum computing, and quantum physics is also known as quantum mechanics, is a branch of physics that studies the behavior of matter at energy at a scale of atom and subatomic particles. And to tell you that why quantum physics is necessary, because quantum physics is very much important from industrial and the theoretical point of view. And quantum physics is important because it's provide a fundamental understanding of the behavior of matter and energy, and it has also led to many theoretical predictions and experimental discoveries. For example, quantum physics has many major applications for the development of uh, various communication protocols. For example, the BB84 protocols, which is very much useful for quantum communication. And quantum physics has led to development of new energy technologies such as solar cells and quantum thermoelectric devices. So I guess quantum physics is very much important because it provides a deeper understanding of the nature of the universe. Okay, so I guess it's very important to understand the nature of the universe, and it has practical application that will be very much useful to transform many fields. Like it has the major applications and the major potential to revolutionize that many fields of study, for example material science. So I guess quantum physics is very much important thing to study right now. And just to explain what is quantum physics is, it's very much different than classical physics. So quantum physics is a branch of it is the same as quantum mechanics. It studies the behavior of energy and matter at subatomic and atomic level. So it describes the behavior of a particle at this level using a set of principles that are different from classical physics. For example, at the core of quantum physics is the particle principle of superposition. So you might have heard about the principle of superposition. So principle of superposition states that a particle can exist in a multiple states or location simultaneously. So that is why it is important to study this principle of superposition. And it has another what I can say, a principle which is called as quantum entanglement. So quantum entanglement is a phenomenon where the properties of two particles can become correlated even when they are separated by a large distances. So I guess both these things are very important for quantum physics, and that is why quantum physics is different from classical physics, because of the probabilistic nature of quantum physics. Because I guess quantum physics is unpredictable, and it's very much different than classical physics. And I guess quantum physics also very much weird, in the sense it cannot be predicted, and it cannot be, we cannot say that it has a certain outcome. So that is why quantum physics is different than classical physics. And to explain it, I can share you example of why quantum physics is different from classical physics. So to explain it, have you heard of uh, uh, what I can say, the the famous experiment by Max Planck? So I guess you might heard of Max Planck, right? So Max Planck did an experiment in which he worked on quantum theory. So in which he did an experiment based on quantum physics. So the outcome of the research was that the particles exhibit a different nature. So he wanted to study the uh, uh, phenomenon behind this, and so he came upon a weird interpretation of the particles. So that's he named it as quanta. So that's how like we were able to get into like a much explanation about what quantum physics is. So that is why like it is very important to understand quantum physics from a quantum computing perspective, and to differentiate between quantum physics and a classical physics. There is a very much famous example from Schrodinger as well. So I guess Schrodinger also explained that the quantum superposition is also different from a very classical physics background. So it is very important to study quantum physics from a quantum computing perspective, and its major application is also uh, in quantum computing and quantum information and quantum field theory. So that is how why quantum physics is very much important.
And like, what are some of the mathematical principles behind quantum physics
Yeah.
and like also
So
application?
yeah. So I guess quantum physics is basically built upon the foundation of mathematical principles and concepts, and it has very much in-depth mathematical equation and formulas. For